Good evening, everyone. This was the last week test related to topic 1.1 to 1.5. So this video is just to explain the questions related to the topic. The first one, student has a measuring cylinder containing water and he's also having a balance. Which of these could she use to find the volume of the metal sphere? So to measure the volume, what we can do, we can fill the measuring cylinder with a liquid, and then we can add a sphere, and after adding the sphere the volume will change, the level will change. So first one, that is a measuring cylinder which is filled with water, and then we place an object, a sphere, the volume or the level will change, and taking a difference of the two volumes we'll get the volume of this sphere, V2 minus V1. That's why B is the right answer. Question 2, which statement describe about the mass is correct, or which statement about the mass is correct? So a mass of 10 kg, weight 1 Newton. So it is opposite actually, because the gravity is 10 Newton per kilogram. So it means if we have a mass of 1 kg, that will experience a force of 10 Newton. So that is wrong. Mass is not a gravitational force, weight is a gravitational force. Mass increases when the gravity increases, that is wrong. Because actually weight depends on the mass and gravity. Weight changes as the gravity changes. So greater the mass, greater the tendency of an object to resist the change in state, or we can also say inertia. That's why D is the right answer. In question 3, a small bottle is there which is having a mass of 20 when empty, and the volume of the bottle is 10. When it is completely filled with a liquid, the total mass is 150. So this was the mass of empty container. Then the mass of the filled bottle is 150. So we want the density of a liquid. So empty bottle is 20 gram and the filled bottle is 150 grams. So the difference 150 minus 20, that is equals to 130 gram. That's a mass. And we need a density. So to get a density, it is mass divided by volume. So 30 divided by 130 divided by 10, that is equals to 13 gram per centimeter cube. The diagram shows a stone of irregular shape. Which property of a stone can be found by lowering into a measuring cylinder? So when we lower this into a measuring cylinder, because there will be a change in the level of the liquid in the measuring cylinder as we lower. So using that concept, what we can work out the volume. That's why C is the right answer. An object of mass 2 kg is taken from Earth, where the gravitational field strength is 10, to Moon, where the gravitational field strength is 1.6. Which row is correct? So what will be the weight on the Earth? We have the formula W is equals to mg. So to get the weight on Earth, the mass is 2 and the gravity of Earth is 10. So 2 multiplied by 10, that's 20. But to get the weight on Moon, mass of an object does not change. So weight is mass multiplied by gravity. Mass remains 2, but the gravity of the Moon is 1.6. So 2 multiplied by 1.6, that is equals to 3.2 Newton. So weight on the Moon will be 3.2 Newton and weight on the Earth will be 20 Newton. That's why D is the right answer. The mass of empty flask is 34. The mass of the total mass of a flask plus liquid is 50. So what will the mass of the liquid inside? So it will be 50 minus 34. That is equals to 16 gram. And the volume of the liquid is 20. So it will be 16 divided by 20. So 16 divided by 20, that is equals to 0.8. Which piece of apparatus is most suitable to measure the mass of a pencil sharpener? So measuring cylinder is used to measure the volume. A meter rule is used to Newton meter is used to measure the weight of an object. A ruler is used to measure the length. So we use a balance to measure the mass of an object. In question 8, what is the best description for the mass of an object? Space occupied by the object is actually the volume. The force of a gravity exerted on the object, that is equals to weight. The resistance of an object to change the motion, that's inertia, or that is due to the mass. And closeness of a packing of a molecule in an object, that is refers to density. Like if the particles are very close, tightly packed, that is refers to density. So C is explaining the idea of mass of an object. Then in question 9, a measuring cylinder contains 40 cm cube of water. A stone of mass 94 is lowered and it is completely submerged. So mass of the liquid is 40. Mass of a liquid plus object, this is 76. So to get the volume, it will be 76 minus 40, which is equals to 36. Now to find the density, density is mass over volume. The mass is equals to 94 and the volume is 36. So 94 divided by 36. So we'll get 2.6. Then a rectangular gymnasium is there, which is 50-meter long, 25-meter wide, and it is 8-meter high. So we have to work, and the density of the air inside is 1.2. What is the estimated mass of the air? So if we have the dimension of the gymnasium, length, width, and height, so we can first find the volume. So 50-meter long is there, 25-meter wide is there, and 8-meter high. So first we'll find the volume, which is 50 times 25 times 8. This will give us the volume. To get the mass is density times the volume. So density is 1.2 and the volume is 50 times 25 times 8. When we multiply all the factors, this will give us 12,000 kilogram will be there, the mass of estimated mass of air inside the gymnasium. The extension in a load graph, the term extension means increase in length. Extension in load graph is there for unstretched spring. So a spring, when it was not stretched, it was 17 centimeter long. When object is suspended from a spring, the length of a spring is 19.2. So when we attach an object, the length of the spring is now 19.2 centimeter. What is the weight of the object? So first, because this is an extension and load graph, so we should know the extension. Extension means increase in length from original. So originally it is 17 and now it is 19.2. So 19.2 minus 17. So the extension is 2.2 centimeter. So from 2.2 centimeter, this is 2.1 and this is 2.2. So from 2.2 centimeter, we have to draw a line to work out the load or the mass which is attached. So according to this graph, a 3 Newton is attached to the object, which will cause the change in length 2.2 centimeter or extension 2.2 centimeter. So original length was 17 and the final length is 19.2. A cart has a mass of 10. So there's a cart which is having a mass of 10 kilogram. A boy pushes the cart horizontally with a force of 50. Like example, a boy is pushing with a force of 50. This is the force of the boy. And the acceleration of this trolley is 0.5 meter per second square. We have to calculate the frictional force. So we need the force which is opposing the motion or the frictional force. So first we'll find what is the resultant force. How we can find the resultant force? We'll use the formula F is equals to ma. So mass is 10 and the acceleration of the system is 0.5. So 10 multiplied by 0.5, that is equals to 5 Newton. So basically the resultant force, as this is accelerating towards the right hand side, so the resultant force is 5 Newton. And what is the resultant force? The resultant force is a difference between the force of the boy minus friction, because these are the two forces which are opposite direction. That's why we subtract. So boy force minus the frictional force is equal to resultant force, which is 5 Newton. So resultant force is 5 Newton. The force of the boy is 50 and friction force is F. This F will move other side and 5 will be on the right hand side. So it will be 50 minus 5, because F move other side will be plus F, and 55 move right side, it will be minus 5. So 50 minus 5, that is equals to 45 Newton. So B is the right answer for this. The structure question is there. An airplane of mass 2.5 into 10 to the power 5 lands on the runway with the speed of 62 meters per second. The airplane decelerates uniformly as it travels along the runway until the speed reaches 6 meters per second at 35. Calculate the deceleration. Acceleration or deceleration, same formula is there. It is final minus initial divided by time. So A is equals to V minus U over T. The final speed is 6, because when it land it was originally 62, but when it reaches a speed of 6. So final speed is 6, initial speed is 62, and how much time it took to decelerate, that's 35 seconds. So 6 minus 62 divided by 35, this will give us the deceleration of the airplane, which is about 1.6. Basically, it will be negative 1.6 meter per second square, but because they mention already deceleration, so you can just write the magnitude here, because the negative sign, it suggests that the object speed is decreasing or it is decelerating. Then we need the resultant force. So to get the resultant force, F is equals to ma. So the mass is 2.5 into 10 to the power 5 kilogram multiplied by deceleration or acceleration, which is 1.6. So when we multiply these two factors, we will get the deceleration, we will get the resultant force, which is about 400,000 Newton. Then at 35 seconds, the airplane stopped decelerating and move at a constant speed. So this is a distance time graph. So distance time graph, how we represent a deceleration. So from 0 to 35, it was decelerating. So the curve will be there, because when the slope is decreasing, it means the speed decrease. And speed decrease means what? It means that is decelerating. So this is decelerating. And then it moves with a constant speed. So constant speed means there should be a straight line, because the slope is constant here. When the slope is constant, it means the speed is constant. And when speed is constant, it means acceleration or deceleration is 0. So this should be the graph for an object which is first decelerating and then moving at a constant speed. This is a distance time graph. Some students think this was a speed time graph and they sketch accordingly. On the figure, we have to mention a range for which it is obeying a Hooke's law. So from 0, because it started from 0, the last point where the line is straight till 8. So 0 Newton to 8 Newton, it is a straight line. That is why we say it is obeying a Hooke's law. And when you use the information, find the value of a spring constant or K. So you only find for a region where it is obeying a Hooke's law. Some student took the total force and the total load and total extension. That is wrong, because we only find, because in this region the value of the K is changing, we only find K from this region. when the line is straight. So you can take any force, it's up to you. Any force you can take within this region. So force will be there, and this is a force, and this one is an extension. So here each box is representing 0.5. So this is 10.5, 11, 11.5, 12, 12.5. Sorry, each box is representing 1 by mistake, because 10 boxes equal 10. So each box is representing 1. So 10, 11, 12, 13, 14, 15. So this is 15 centimeter. You can convert into meter, but it is 15 centimeter, and here the force is 8. So it will be, the value of the K is force divided by extension. So 8 divided by 15, we'll get as 0.53 Newton per centimeter. So this answer will be 0.53 Newton per centimeter, or you can also convert, like get the answer in Newton per meter. Then the next part, the second spring, which is identical to the first spring S, and two springs are stretched. So look, whenever we attach two spring end to end, so what will happen, like if I apply a force or load 4 Newton here, the, then what happen, both will experience 4. Like this spring will experience 4 Newton, the other spring will also experience 4 Newton, because the total force of 4 Newton each spring will experience. So this will experience 4 Newton, this will also experience 4 Newton. But if this was connected in this manner, like separately two springs are there, and then we attach a 4 Newton, a load of 4 Newton, then what happened? This 4 Newton will be divided 2 Newton experienced by each spring. But in the question, when they are connected end to end, so the load which we attach here, that is a load experienced by each spring. So each spring will experience a load of 4 Newton. So state the name given to the energy which stored. So whenever objects store energy due to change in shape, size, or length, we call that as elastic strain energy. Then determine the extension of the arrangement. How we can determine the extension? So first what we do, we are attaching a 4 Newton load. So when we attach a 4 Newton load, each spring will experience 4 Newton. So 4 Newton is experienced by this spring, 1, and the 4 Newton is experienced by the second spring as well. So for using a graph, first we'll find how much extension is produced, because this is the original graph which was given for each spring. For one spring, when the load or the force is 4 Newton, the extension is how much? So this is between 7 and 8. So this is 7.5 centimeter. So each is experiencing a load of 7.5, like extension of load is 4, each is experiencing a load of 4, and extension is 7.5. The question is, what is the total extension produced? So how we can work out the total extension? If it's each spring, like the change in the length for the first spring is 7.5, and change in the length for the second spring is also 7.5. So 7.5 plus 7.5, so that is equals to 15 centimeters. So the total extension will be 15 centimeter. Then the load is carefully increased to 6 Newton. Calculate the total distance moved by the load to a new equilibrium position as the load is increased from 4 Newton to 6 Newton. So how we can work out? Basically, we can use a simple ratio here. The force is 4 Newton and the force is changed to 6 Newton. So how much the force changes? The force changed by 2 Newton. And we have the formula, force and extension are directly proportional. Whenever two quantities are directly proportional, their ratio will be constant. So if we are applying, example, in the previous one, we were applying a force of 4 Newton. So the force of 4 Newton was causing an extension of 15 centimeter to the whole system. But if the force is increased, change by like changing from, because we don't need the total extension, we know need only the extension when the force changes from 6 Newton, 4 Newton to 6 Newton. So when the force is changed by 2, because changing from 4 to 6 is changed by 2. So how much is the extension? It will be x cross multiply. So it will be 15 multiplied by 2 divided by 4. So that is equals to 7.5 centimeters. So you can use the ratio and you can get the answer. Also, there is also another way. Like as we work out, like what we'll do, we'll work out when the force was 4 Newton, the extension was 15 centimeter. Now, if the force is 6 Newton, how much is the extension? How we can work out? We have to use a graph, because the graph is for each spring. So total spring, it will be for 2 springs when they're connected end to end. So it will be double. So when a force is 6 Newton, extension is 11. So that is for one spring, but because the 2 springs connected end to end, and if we attach a 6 Newton, so this spring 1 will experience 6 Newton and spring 2 will also experience 6 Newton downward force. So the total extension for each spring is 11. So total extension for 2 springs, each will increase by 11 centimeters. So total extension will be 22 centimeter. So in the question, and this is not exactly as, because I took the number here, but it is between like 11, it is a bit above 11, so I can also say 11.5, 11.25. So not exactly 11, it is there 11.25. So if each spring is having 11.25, total will be 11.5 plus 11.5, so it will be 22.5. So this is 22.5. In the question, they're asking what is the increase in the length or change in the length when the force is changed from 4 Newton to 6 Newton. So when the force is 4 Newton, it was 15 centimeter extension. Force is 6 Newton, it is 22.5 centimeter extension. So the difference 22.5 minus 15, so that is equals to 7.5 centimeters. So both ways you will get the same result. It won't make difference to the final answer. The structure question is there: a car is accelerating from rest to its maximum speed. The speed of time graph for first 25 seconds is shown. The mass of the car is 2300. Determine the acceleration for 0 to 5 seconds. So acceleration is a change in velocity. Each box representing 1, because 10 boxes are 10. So each box is representing 1. So acceleration, whenever it's a straight line, we can use a gradient or final minus initial divided by time. So at 5, this is 15 meter per second and the time is 5. So it will be 15 minus 0 divided by 5. So 15 minus 0, 15 divided by 5, that is equals to 3 meter per second square. So after getting the acceleration, we need the resultant force. F is equals to ma when mass and acceleration are there. Acceleration we work out 3, and mass was given in the first part, which is 2300 kilogram. So F is equals to ma. The mass is 2300 times 3, so it will be 6900 Newton, the resultant force. Describe the motion of a car from 10 second to 15 second and explain how figure 1.1 shows that. So first, from 10 second to 15 second, what we observe? We observe the slope is decreasing. In this part, what happened? The slope is decreasing. When we check the y-axis, speed is increasing. If the slope is decreasing, speed time graph, what slope represent? Acceleration. So what happened to acceleration? The acceleration is decreasing. But what happened to speed? The speed is increasing. Because speed is on the y-axis. You can see when it is at the 10-second mark, the speed is about 26. And when it is at 15-second mark, speed is about 29.5. So speed is increasing, but the acceleration, the change in the speed is decreasing. But you don't say deceleration, because deceleration is a term which can only be used for decreasing speed. So here the answer, why is of 3 mark? 1 mark is for mentioning the slope is decreasing. Second is which shows the acceleration is decreasing. And the third mark is for mentioning that the speed is increasing. Or you can start with speed increasing. The acceleration or the change in speed is decreasing. And third, how you can identify, because the slope is decreasing, because the slope represent acceleration for speed time graph. Then the next part, from 10-second to 15-second, the force exerted on the car due to the engine remain constant. Explain why the car moves in this way. Like from 10-second to 15-second, as you can see, the car acceleration is decreasing even though the engine force is constant. So what is the reason for that? Even though the force of the engine is constant, like example, if I say the car is moving towards the right hand side, so this is the direction of the motion. So if the car is moving towards the right hand side, if this was the original, like these are the three positions for the car. As you can see, speed of the car is increasing. Here, example, speed from 10 to 15, if we take the number, at 10 it was 26. Then it example turned into 27, and then it turned into 29.5. So what happened? The speed of the car is increasing, but the force of the engine is constant. Engine is not changing the force. So if I use a number to explain the idea, like force of the engine is 100 Newton. Force of the engine is 100 Newton in each case. But because the speed of the car is increasing, so air resistance, the force which opposes the motion, will also increase. The first, because the slower speed, the air resistance is less. But as the speed is increasing, air resistance will also increase. So here example, the air resistance is 20 Newton. At this point example, the air resistance is say 40 newtons, and at this point the air resistance is 70 Newton. So what happened to the resultant force on the car? As the speed is increasing, so resultant force on the car, the air resistance also increase, so resultant force on the car decreases. Because the resultant force 100 Newton right and 20 Newton left, so resultant force is 80 Newton. Here 100 Newton right, 40 Newton left, resultant force is 60. And here 100 Newton right and 70 Newton left, so resultant force is 30. So you can clearly see the resultant force is decreasing. That's why the acceleration is decreasing. So how you will write the answer? When speed of the car is increasing, the air resistance or the frictional force will also or you can also say drag will increase, because air resistance is directly proportional to this the speed of the object. the force of the engine does not change, so the resultant force on the car decrease, which reduce the acceleration. That's why the acceleration of a car is decreasing. That's why from 10 second to 15 second, you will find for a speed time graph, you will find that the slope is decreasing. Speed on y-axis and time on x-axis. And once the speed and is constant, it means that moment there is no resultant force. The air resistance balance with the force of the engine. So this was the test related to topic 1.1 to 1.5.